So back to what we were talking about, why it's favorable, because I spent $435 and I thought I was going to spend $450, so I actually spent less. So let's plug in our numbers for our quantity variance. So our standard quantity is going to be 18,000. Our actual quantity is 18,500. And our standard price is $450. So that is going to equal, we had a unfavorable variance of 500, and then we're going to times that by 450. So we get 2250, and this is actually more than what I thought I'd use. So this would be unfavorable. So when we look at this price variance, this is letter A, and then quantity variance, this is letter B. The last part is going to be part C, and this part is where we net the 2775 and the 2250, and so we get 525. This is favorable because when we break this down, we see the reason. Remember, we had more favorable than unfavorable. We have this favorable variance up here because we saved this $27.75 worth of price. We paid less than what we expected. But down here, we use more material than we thought. Just think of how great it would have been if we would not have used more than we expected. So let's say we can fix a machine that's eating up our fabric and using more materials than we should. Then we should have 0 of this because we would have used the right amount and we would have a favorable variance because we got the material. We got that material. However, it could be showing us something different. It could be saying, hey, you're paying less money than you thought, but maybe you're substandard material, maybe you're getting poor material that shreds more easily and creates more waste. So the manager can take this information and figure out what's happening and make changes if necessary. And this is the way that the book explains it. So look at it in this format and see which one makes more sense. Okay, we're going to do the same thing for direct labor variances. Remember, instead of calling it price, they're going to call it rate. And instead of calling it quantity, they're going to call it time. But it is the exact same formula that they use. We've got direct labor cost variance of 2,500 of 5,000 XL jeans, and it was made up of this difference. So the actual cost incurred of $38.5 was the actual rate times the actual time. That's how we got the $38.5. And our standard cost was the standard rate times the standard time. So if the actual rate exceeds the standard rate, we paid more per hour than we expected. and that would be unfavorable. If the reverse is true, if we if the actual direct if we actually paid them less than the standard rate, then we would have a favorable variance. And then next we will do our quantity variance, which we're talking about direct labor. We will call it time variance. So same thing here, we've got direct labor hours, which is a quantity of time. So we're going to do actual minus standard direct labor hours, and we're going to times it by, we just did hours, so we need to times it by rate. And this is our second one, so it's going to be the standard rate. We plug it in. If it's favorable, we'll call it favorable. And if it's unfavorable, we'll call it unfavorable. Just like direct materials, we can look at the total 2,500, and then we want to break that down and find out how much of the variance was caused by a rate variance versus a time variance. So if we have 3850 unfavorable, but 1350 favorable, we can see that our unfavorable is higher than our favorable. So our net became unfavorable because that was our higher number. So this could help managers in a lot of different ways. They would look at these variances, and it could show that they are not scheduling them properly, that they may have some people that are working and not able to be efficient, and we may have overscheduled. It could also show that maybe we're using a higher priced person, a more skilled person for jobs that can use a more lower skilled person. So there's all sorts of information that we can get from these variances and then make changes as needed. So I just mentioned some of this so you can kind of look over this slide. And we are going to work this example exercise over direct labor variances. We'll be looking at the direct labor rate variance, which remember is the same as the price, and direct labor time, which is the same as quantity, and we'll get the total. And we're going to work this in Excel, and I'll also show you the book answer. That way, the way that this PowerPoint presents it right here, and then you can decide which way you prefer. Okay, so the problem is going to work the same as direct materials, but now we're looking at direct labor instead. So I've changed the heading. So instead of price, it says rate. And now it says, instead of quantity, it says time. But everything else is the same. So as always, the hardest part is going to be going through the information given and picking out the important parts and identifying what they are. So let's look. Tip Top produces a product that requires 2.5 standard hours per unit at a standard rate of $12 per hour. If 3,000 units required 7,420 hours at an hourly rate of $12.30 per hour, what are the direct labor variances? So let's do our rate first. The standard rate is $12 and the actual rate is $12.30. So the difference here is 30 cents. So let's see if this is favorable or unfavorable. I thought I paid 12, but I actually had to pay them $12.30. I paid them more, so this would be unfavorable. Okay. let's do our time. So we thought it was going to take 2.5 standard hours per unit, and we made 3,000 units. So let's do 2.5 times 3,000, because 3,000 is our standard. And so that would be 7,500, but we're told that our actual is 7,420. So it took us less time than we were expecting. So less time is more efficient, so that is favorable. I always leave this part blank, because the more times we can talk about the formulas and actually write the formulas out, the better we'll understand it. So the rate variance, and I need to change that to rate. I'm going to put rate variance there, and I'm going to put quantity. Let me go ahead and put time there. I meant to change that. Okay. So we're going to be looking at rate variance. So it's going to be our actual rate minus our standard rate. And then we're going, remember, you always multiply by what you're not doing. So we're doing rate, we're not doing time. This is the first one, so we're going to do the first one, and the first letter is A in the alphabet, so actual and then time. Well, I'm in the mode of remembering formulas. I'm going to skip down and do my time variance. So we're figuring time, so we're going to do actual time minus standard time. So we're figuring time, and since we're figuring time, we're going to multiply it by rate, and we've already used actual, so we're going to do standard rate. So let's plug it in. So my actual rate, let's go back up here. My actual rate is 1230 and my standard rate is 12. So 1230 minus 12, and then I'm going to times it by my actual time, and my actual time is 7,420. So this is 0.30 times 7,420, and that is going to be 2226, because we already determined it's unfavorable, so we can just go ahead and put unfavorable. And then let's do our time. So actual time is 7,420 minus standard time, which is 7,500, times our standard rate, which is 12. So let's do that. So 7,420 minus 7,500 would be negative 80. And then we're going to times it by our standard rate, which is 12. So we get 960. And this one is favorable. And so for our example exercise, we have had, and for this, our example, we've had favorable and unfavorable. They can be favorable or both unfavorable, but in this situation, we have a favorable one and an unfavorable. So Part C asks us for total direct labor cost variance. So we would say 2226 plus negative 960, and we get 1266, and this would be unfavorable because our higher one was unfavorable.